Hello, scientists. It's Mrs. Deming. I'm going to make a quick video to help you do this assignment where we are going to look at making a mind map of some of the terms that we have been learning to figure out kind of how they all go together. Okay, first thing I want to do is go through this list and determine which terms we already know. So take a look at it and see if you can figure out which list or which words we have already learned. Okay, so I see that we already know amplitude, energy, frequency, electromagnetic waves, hertz, medium, maybe propagation, rest position. Down here, those. Now, I'm going to say we know a little bit about space. We've talked about that. We've talked about transverse, wavelength, high energy, high frequency, low frequency, short wavelength, long wavelength. And that's it. So from these words, we're going to create a mind map or kind of show how they're all related. So I'm going to start with putting waves on the top of my paper. So if you can grab a piece of paper, pause this video, go grab any piece of paper, and you can kind of do this with me. We're going to put waves up at the top. And I noticed to myself that there's a couple words that are missing, so I'm going to add to the list. So I added mechanical, but actually electromagnetic waves are already on there. So waves can be broken into kind of two categories. They are mechanical and electromagnetic. And then maybe we want to put something up here. What are waves? Waves are how energy moves from one location to another. And there are two waves. One or two types, two. Okay, mechanical. These guys require energy or require matter to propagate. Propagation is one of our words, so I'm going to put that. Propagate means to move. And the matter, this is our medium, what the wave travels through. So that's another one of our words. Okay, so we have done energy. We have done medium, propagation, and mechanical. Okay, electromagnetic waves. That's on our list too, electromagnetic waves. Cross that up. They can travel through matter, but they do not require a medium. So there's our word again, medium, material that it's going through. So these guys are important because if they do not travel, they do not require matter, they can travel in a vacuum, which is where there is no molecules. And this could be like space, outer space. which is important because this is how energy gets to us from the sun. So we've done electromagnetic waves, medium. I thought I saw on here vacuum. Yep, so we'll put that as a check, and we're going to cross it off. Okay, so mechanical waves also come in two types. Okay, so we're going to draw another kind of branching thing. They can be this type or this type. So we're going to have either longitudinal or transverse. And this all is about how the matter and the energy are moving with each other. So in a longitudinal, there, if you remember with our slinky, there were spots where the slinky coils were really close together, then there were spots where it was far apart, and there were spots where it was close together. In this one, I moved the slinky forward and back. So this is the matter, and the energy went this direction, forward. So this is the energy. We describe those two motions as being in the same direction or parallel. And an example of this type of wave is sound. Okay, a transverse wave, how this one is different. This is our more traditional kind of wave shape where we have this shape, and that's because the energy or the matter moves side to side or up and down, and the energy moves across the page. So these guys are, the matter and the energy are going in, are perpendicular to each other. So matter and energy are perpendicular, which kind of looks like an upside down T. They're at right angles to each other, perpendicular. These guys are parallel, and there's lots of L's in the word parallel, which remind us of longitudinal. This is perpendicular, looks like an upside down T, which reminds us of transverse. Once we do that, so let's see, we've got some more words that we just used. We used transverse. We used, I don't see that longitudinal is on here, so we need to add that. Okay, so we're going to label some parts of this. This point here is the rest. The top is called the crest. The bottom is called the trough. The distance from one wave to the next is called the wavelength. And the height of the wave is called the amplitude. Okay. That crosses off a bunch of things for us on our word list here. So we did wavelength. We've also talked about space. Talk about rest. Okay, so we have some things we can do here. Amplitude, we can have different types of amplitude. If I can draw that. One. This is a low amplitude. This is a high amplitude. Equals low energy equals high energy. If we do wavelength down here, we can draw different wavelengths. This is a low wavelength. This is a, I'm sorry, this is a short, we say short. This is a long wavelength. If we have a short wavelength, then we know something is true of its frequency. It has a high frequency. This one has a low frequency. Transverse waves, an example of these would be ocean waves. And we're going to find out that electromagnetic waves also have that transverse shape. Well, I think that gives us a good start. This is also a really good review for tomorrow's quiz.